Yeah, DJ Row keeping it cool once again, you know what I'm saying? No pain, no gain. You know what I'm saying? So yeah, welcome to another class from Belfield. And this this is our I think this is our fourth class and the topic of measurements. And again, this is for you students in grade 9 at Belfield. Or as they would say, third form. Yeah, so good to have you here, guys. And actually, our plan for you now is to go one step further on what we did in the previous class. And I remember leaving behind an assignment where you were supposed to look at um, some measurements. In fact, it consisted of some blocks, and I'm gonna bring that up on the screen. But it's consisted of some bars that were put against a ruler, and you were asked to tell the measurement of it. And so while that's taking place, um, we're gonna show you. Okay, so we're gonna do some recap. As I wanted to get this on the screen, so let's just share this one. Here we go. All right, you should be seeing it now. And what you're seeing here, it's interesting that we have there a red bar beside transparent looking ruler with centimeter markings on it. And the question would be, okay, what is the measurement there? Okay, what is the measurement? I said identify the length of the bar to the nearest tenth. Actually, the tenth. What do we mean by the tenth? Well, we have let's look at the numbers first. 0 to 1, and the 0 all the way up to 1 is divided into 10 equal spaces. So hopefully you can see that. So the spaces between 0 centimeters and 1 and 10 spaces. So, and we're gonna have to learn how to count that. All right, let's get a color here that we can identify easily. So there's 0, and of course this is 1/10. This it's gonna get should learn at 0.1, and then you're gonna have 0.2. Let's get this line. It's gonna be 0.2. Okay, this one will be 0.3. So if we could zoom in so we can get that separation of the numbers so that it's not confusing. And let's move these numbers, move this one, and let's fix it up. Okay. So yeah, again, DJ Raul keeping it cool once again. You're listening to it's a track that I built, that I created, and it was for commemorating, well, a housemate of mine leaving, and so it's called the Leaving Rhythm. Yeah, so that's a side note though. So if you hear anything in the background, that's what is playing. As a matter of fact, so just this, sharing the sound as well so you can hear it. All right, so it's the Leaving Rhythm. Yeah, you know what I'm saying? People learn well with music in the background. It could be you. Doesn't matter to me. I'm a musician at heart, but can learn without it. And while you're listening to that, I'm here showing you the divisions that this ruler has. The divisions between every number. So the distance between each number and the ruler is divided by into 10 spaces. All right, they're equal distance. The distance between 0 and 1 is the same distance between 1 and 2, and then the distance between 2 and 3 is the same thing. So the distances are equal, and also each of these distances are divided into 10. So we're just gonna add the small units to the larger unit to get the measurement, and that's the skill we're gonna learn today. All right, so we're at 0.6 right there, and this should be 0.7. All right, right here would be 0.8, and of course we have 0.9 right here, and then of course after 0.9 comes 1.0, so this one would actually be 1.0. So we could write this as 1.0, and then we wouldn't have to label it. But then that is it. That's the principle here, guys. You know, so you have 0, 0.1, 0.2, and if you notice, the first small space between 0 and the 10th here is actually 0.1, and 0.1 is a fraction of the space between 0 and 1. It's actually 1/10, and you know, 1/10 of times 1 is gonna be, well, 0.1. Put that on the calculator. All right, so that's a 10th. So we're gonna say 10th equals 1/10, and you multiply that by 1, and it's actually going to be 1.0. That's going to be 0.1. That's the number. Identify the length of the bar to the nearest 10th. That's what they said, to the nearest 10th. And so to the nearest 10th, what we have here is, look at this. The bar stops right here, guys. And we apply the same principle here. Count the number of spaces. Count the number of small spaces now that line up with the object that's placed beside the ruler. All right, now we have 2, so 2 is the largest number, and then after that, the smaller scale, we add the smaller scales, which is 1, 2, 3 of the smaller scales, 0.3 to the nearest 10th, they say. So they're gonna be a little bit over 2.3, but then we're just gonna, well, that's why they say the nearest 10th. So we're gonna get 2.3 for this one, guys. You should get 2.3. Unit is in centimeters. Answer is wrong without the unit. If you have any questions, post them in the comments. All right. So, well, we are at this now. We're gonna send that link in the group, and let's go. We're gonna send this link in the group, in the classroom, and I'm gonna shift A. All right. Okay, so let's send this on. Okay, today is actually the all right, so I'm gonna put the link here. All right, so here you go, guys. Just a sec. I'm gonna get this one. There you go. Yeah, I should send some notes this week as well. Didn't realize I didn't send any last week, including the worksheet, but the video was there. You could have written it off. But then, well, cool. So this is how you read it, right? So again, just follow the same principle here. This will always be 0.1. This will be 0.2. Then this one will be 0.3. Then we'll just add the 2 to the 0.3. You get 2.3 here. That's how you read the ruler. All right. As I said, if you have any questions, you put them in the group, and that's it. All right. Also, we have the link as well. So the link could be here, and here it is. All right, here it is. And so then there you got that as a link. And we're going, guys, we're going. We gotta go. I have to pass through this topic today. All right, so with that knowledge now, guys, let's go on over. Again, here are the rules, here are the summary of it. Start from 0, read the first to the nearest centimeter, and of course start from 0, and they go 0, 1, certainly 1, 2, and so it's going to be 0. You got the 1 there and 2. All right, and that's where the arrow points to it. Read the next nearest millimeter. And so what happens here is that the smaller reading is actually in millimeters, but yeah, there's a millimeter is actually a tenth of a centimeter. All right. The red tape, according to this, is 2.3. We showed you how we got that a while ago. All right, so let's apply it to this now. What would these be? And if you observe this carefully, this was been the assignment. This would have been the assignment from the previous class here. Certainly, yeah. All right, so what we have here now. So measuring in centimeters here, guys. We have. Let's see. Let's look at this. This is interesting. Let's zoom in. There's a stuff red tape beside the ruler here. I'm going for the same principle. This also is divided into 10 spaces. So you got 1 here, and that you can take off 2. 2 is covered. 3 is also covered. 4 is covered, and does it make it all the way to 5? So measuring in centimeters to the nearest centimeter, this seems to be about 5, and we're gonna say 5 here. It will definitely be 5.0. And of course, centimeters. You want to make sure you have your units beside your measurement. Get in that habit, students. And again, to the nearest. That's crucial here. It all depends on the observer. And then that's why in the last class we discussed the error, because errors could come from misusing the instrument, maybe not reading the scale properly. And so in the next class, we'll speak more on that matter. But in every measurement that we undertake, there will be errors. All right, just understand that. All right, in every measurement there is uncertainty, and the uncertainty is the error. And then when we reach here, in a practical sense here, we're seeing that okay, we're uncertain if this red tape actually reaches the 4 mark. And so we say to the nearest 10th, it would certainly be 4, and to my eyes it looks like it's near to 4. All right, so let's give it 4. All right, so it's gonna be 4.0 centimeters. All right, so you should be able to do the rest. So we can at least attempt to move on from here. Because the next issue here is the limit of the accuracy. I think we spoke about this last week, but here we have it. Then how close the measurement is to its true value. This is restricted or limited by the accuracy of the measuring instrument. All right, so the ruler is marked in centimeters, so any length measured with it can only be given to the nearest centimeter. All right, the instrument has limitation, guys. What if it's smaller than a millimeter? Can the ruler tell you that? And no, the answer would be no, because well, it's not accurate enough, right? And then we're gonna learn that the more decimal places we have on readings is an indication of the accuracy of the instrument we are using. All right, so let's go here. Limits of accuracy. That's what we have here. All right, very good. For each of these, all right, so for each of these, state the limit. Okay, we're going to say the size of 1 unit here. So for each of these measuring scales, state the size of 1 unit on the scale and state the limit of the accuracy. Again, the limit of the accuracy is the smallest measurement that the instrument can give you. Smallest measurement it can give you. In the case of the ruler we used before, the limit of its accuracy, the smallest one it could give is actually 0.1. And so that's the accuracy of the instrument. But then these are different now. These are actually different scales. This has something in kilograms, and then when we learn the basic units, we realize that well, mass is measured in kilograms. Of course, milliliters is one. If you can see it clearly, this is actually milliliters, which this is measuring volume. All right, so it's milliliters. And then of course this is volume. All right. And all right. All right. All right, so yeah, that's what we have here. And yeah, just a minute. I actually got a bit distracted, so it's cool. And then looking good. All right, so yeah, persons are actually liking my post, my video of class yesterday evening, which is open to any Belfield student actually. Always happy and you know, welcoming of Belfield students. You know, they hold a special place in my heart, and you know, if you need extra classes, I'm here for you guys, right? So I'm here for you, just know that. All right, so then we have the mass measured in kilograms. Sorry, I made a mistake here. I don't know why I put volume here. It's actually mass. Why am I doing this? This is mass. My bad, forgive me. Okay, here we go. So the size of one unit is 1 kilogram. The limits of accuracy are plus or minus 0.5. And then of course, what this is saying now, it's plus or minus 0.5 times 1. What on earth are they saying here? Well, all right, let's see. It goes from 80 to 90. Those are the numbers we are certain of, which means that, well, the same thing. If it divides into 10 places, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It divides into 10. Okay, so in the middle would be 0.5. That's the rule, generally speaking. And then every one you count is going to be a point there. And then, that, of course, this one will be 0.9. All right, so actually going to be 0.9. So you say 80.9 at the last mark here. But then this is interesting. It's actually a 10. We have to go back here. We have to erase all of this. I'm misreading it. So never you make that mistake. What we're doing here is simply trying to read this mass scale. And this one is a little different because, well, it's divided. It's only 1, goes up by 1. So this would be 81, guys. Sorry, 82. And then, of course, 83 would be here. 84. 85. And remember, going from 80 to 90. 80 to 90 is 10. We divide that into 10 parts. So, again, that's the size of 1 unit is a kilogram, which is true. The distance of the smallest interval, the smallest space, is 1 kilogram. Hopefully you see that. So then this here would be 79. Here would be 78. All right, here would be 77. Here would be 76. And this one would be 75. So we could put the 75 there. And so 1 kilogram. So the size of 1 unit is 1 kilogram. The limits of the accuracy are plus or minus 0.5 times 1 kilogram. All right, and interesting that they put there 0.5 kilogram, because if the measurement falls between like 2 numbers, then they will say it's 0.5. Okay, well, that be stretching the accuracy in my opinion, but then if they say that, well, let's confirm that. And then I think this is universally accepted, where if your reading falls between, it's just like the meter, you know, the light meter that you would have when the reading falls between 2 numbers. So that's a GPS meter, or I don't know if they still have these, but let's bring up one and show you. Okay, GPS meter, the old ones, and there it is. They use that similar scale. All right, let's go to a new slide and show you this quite quickly. And here it is, guys. Here it is. Yep, there you go. GPS meter. I don't know what's happening here. And probably not clear. Get some more clarity on this one. And let's use this one. Let's remove this one. This one kind of blurry. So let's carry this in. Probably this one a little bit easier to read. Let's just get that out of the way. All right, hopefully you can see this one. The scales here. As you can see some readings here. This mark falls between 2 numbers. This thing happens from time to time with analog scales, but then it's one of the things we have to work with in physics. All right, so if it falls between halfway, you could say 0.5, I guess. And then for being on the size of 1 unit is 5 milliliters. Well, let's see, because it just goes from 5 to 10. Note that there are no small markings between the 5, 10, 15, 20. It's just going straight up by 5. The limits of the accuracy are 0.5 times 5 milliliter, that's 2.5. So what they are saying actually is if it goes halfway in between, you could say, well, okay, you could say that this is 2.5 and then this would be 7.5. And then you keep adding 2.5 exactly between each of them. So this is 10. It's going to be 10.5, rather not 10, but 12.5 rather. And that's the space between 10 and 15. All right. Adding 2.5 to 15 will give us 17.5. We'll just draw this in green here. 17.5. And of course, here will be 22.5. So that's what they're saying here. All right. Well, I suppose that it's limited there by the accuracy is limited. All right, guys. I think that's it for our class today. And so if you have any questions or comments or concerns, you just hit me up in the chat. All right. Yeah, you can send me in the chat. You can reach me in Google Classroom. Those of you who following the class based on the MOE Google Classroom account. But otherwise, you can reach my channel and you can go there and subscribe and you'll know when another video is up. And also you can participate by just sharing a comments or just commenting. All right, guys, so that's it for today's class. Join us and next week Friday. We're pushing it to Saturday. Join us next week Friday at the same time. Grade 9A students or 3A students. It was a pleasure having you this morning. Hope to see you guys again.